Hey guys, this is Worm from Worm's Maths Academy. Hopefully you've recovered from yesterday's exam and you're firing up for today's exam. Something strange, we've got 5 questions, so the fact that we've got 5 questions, I think this is probably going to be pretty long, which doesn't bode well for you guys. But anyway, okay, first one, period of a function, it's cos, so it's going to be 2 pi on 2 pi on 3, which is just 3, so C. The maximal domain of this function is all real numbers except for 1. So when can it not equal 1? If I put 1 on the bottom of that, it's undefined. It's going to be defined for everything else, so it's going to be A. Okay, consider the function 1 on x from A to B. A and B are positive real numbers. So A's got to be somewhere here, and it's a decreasing function. B's got to be some here. If I put A into that function, I get 1 on A. That one's closed. And then here, if I put B in this function, that's open, and it's 1 on B. So my range is 1 on B open to 1 on A closed. Okay, point lies on the graph F. A transformation maps the graph of F to the graph of G, where G is a half f of x minus 1. The same transformation maps the point A to the point P. The coordinates of the point P is R. So it's translated 1 to the right, so that would be 4, 2, and then it's dilated a half from the x-axis. So our y values are halved, so I get 4, 1. Okay, there's a stationary point in the graph when x equals negative 2. The value of P is a stationary point. So dy dx equals 0 when x equals negative 2, x squared plus px. X squared plus p divided by x. Okay, we want the derivative of that equal to 0. Calculation diff, and then solve, but that given x equals negative 2, and solve for p. P is equal to 8, assuming I didn't stuff anything up. P on x is a stationary point on the graph when x equals negative 2. So d dx equals 0 given f equals negative 2. Let's try it. Oh, there's a double derivative, you idiot. Copy. Paste. And then let's get rid of that. And let's paste this into here. And then hit enter on it. P is negative 16. Okay, so that's better. The derivative of that equals 0. Solve for P given x is negative 2. Let's make sure you haven't. Stationary point, x equals negative 2, so P must equal negative 16. Let f and g be two functions such that f of x is that and g of x plus 2 is that. So if I want to get g of x first, g of x is going to be, I've got to replace x with x minus 2, because I'd have to go g of x minus 2 plus 2, which means wherever I've got an x, I replace with an x minus 2. So 3x minus 2 plus 1, which is 3x minus 6 plus 1 is minus 5. And then f of 3x minus 5 is going to be 2 times 3x, which is 6x, and then minus 10. 6x minus 10. Okay, let that function be that. So k log 2 of x. K is an LR. Given that f inverse of 1 equals 8, find the value of k. So let's find f inverse. x equals k log 2 of y. So x on k, 2 to the power of that, is equal to y. And we know when x equals 1, y equals 8. So let's put that in. 2 to the 1 on k equals 8. 2 to the 1 on k equals 2 to the 3. 1 on k equals 3. K equals 1/3. Okay. 1 to 12. And then 12 to 5. Okay, so if we did 1 to 5, g of x dx, plus 5 to 12, 5 to 12, g of x dx, we know that that's 6. And then here, I did is equal to 1 to 12, g of x dx. So in this case, we want to find 1 to 5, and then 5 to 12 is equal to that. So we get that is equal to, because that was equal to 5, that, when I change them around, that would have been positive 6, so this is going to be negative 1. Okay, tangent the graph at log e2x has a gradient of 2. So the gradient of that is 1 on x. If I let it equal 2, I get x equals a half. The tangent will cross the y-axis, so I want the equation of the tangent when x equals a half. Log e2x. Clear. Log e2x. Calculation line, tan line, when x equals a half. Okay, so my y, is it y-intercept or x-intercept? Y-axis, was it 2x minus 1? I think it was. Yep. Go the other way. Okay, the function with that property, which of the following is a possible rule for the function? So f of x equals 1 minus x. Define f of x equals 1 minus x. Then we want to judge and then we want to judge, double click, was it f of x plus f of x, f of 2x. F of x plus f of x, stupid thing, f of x plus f of x equals, is that what it was? F of 2x. Bloody hell, I don't know if I can type this out right. 2x. All non-zero real numbers, x. Oh yeah, why is it bloody doing it? Okay, given x doesn't equal 0, enter. Okay, I think the next one was x minus 1, false. What was the next one? X. True. So it is x. The graph of y equals tan ax has a vertical asymptote at x equals 3 pi. and has exactly one intercept, so it's got to go through once over here. The value of A is. So it's got to intersect there. It hasn't been translated left or right. A period has to be 6 pi, or at least 3, so greater than 3 pi. So I'm going to go tan AX and then change the value of A and see what occurs. And I'm going to sketch x equals 3 pi as well. So tan AX, tan A times x, and let's also sketch x equals 3 pi, undefined variable. So, okay, so if we said given A equals 1 on 6, I think was the first one. Sketch it. Okay, that has an x-intercept on 0, so that's no good. What was the next one? 1/3 and then 1/2. Come on. 1/3. What? A is a positive real number, has exactly one intercept in that region. Okay, so we can't include the first intercept, there's got to be another one. So there's still not one. When it was 1 on 6, what did we get? Still not 1. 1 on 2. Okay, we've got one intercept. The one at 0 isn't included, so it's 1/2. C equals 1/2. Okay, discrete random variable x has probability distribution. Let me be the mean of x, so let's find the mean. E of x is 9 on 20 plus 2 on 10, 2 on 20, 3 on 20, 18 on 20. So what's that? 11, 14, 32 on 20. So that's what our mean is. The probability that x is less than 32 on 20, even if it's 34 on 20, isn't it? 11, 14, yeah. No, that's right. Okay, so that's less than 2. So it's just going to be 1/4 plus 9 on 20, 5, 14 on 20, 7 on 10. Okay, a particular scoring game. There are 2 boxes of marbles, and each player must select 1 marble from each box. The box contains 4 white marbles and 2 red, the first one. So, white, red, 2 out of 3, 1 out of 3. That's box 1. And then box 2 is going to be 2 white marbles, 2 out of 5, and 3 red. So white, red. White gives you a score of -2. Red gives you a score of 3. -2, 3. The points obtained from 2 marbles randomly selected by a player are added together to obtain a final score. What's the probability of score 1? So it's that, or that and that. So white and red, 2 on 3 times 3 on 5, plus 1 on 3 times 2 on 5. So that's going to be 6 on 15 plus 2 on 15. which is 8 on 15. Okay, two events A and B are independent. The probability of A is equal to the probability the probability of B is 2 times the probability of A. Probability of A is equal to, they're independent. Okay, so let's start. If I had 0.1, I would have B is 0.2, so this is probability of B plus the probability of A. That'd be 0.1. And then I'd subtract those two things multiplied together, which is 0.02, which isn't going to give me 0.52. So it's not that. 0.2, I would get 0.4 plus 0.2 minus 0.4 times 0.2 is 0.08, because we know that if they're independent, the probabilities multiply. And that is 0.52, which is A or B. So that's 0.2. Okay, probability density function is that 1 on 12, 8x minus x cubed between 0 and 2. Get off, you stupid thing. Okay. Clear all. Okay, that didn't look like it had 0 to 1 on 12, the median 1 on 12, 8x minus x cubed. 1 on 12. (8x minus x cubed) dx. Now, I'm not going to let it equal half because I don't want to solve it. So I get that is equal to 1/2. Simplify. So I'll say minus 1/2 equals 0. (48) times all of that. Okay, negative m to the 4 plus 16m squared minus 24. So I can also do that the other way. Stupid thing. Just go away. Was that plus and minus? I think it's that. It definitely had a 24 in it. Okay, so take out a negative. We're going to have m4 minus 16 plus 24. Okay, that's E. Okay, doesn't approximate the area of the x-axis. 2 cos 2x plus 3 over the interval 0 to pi and 2, 3 intervals, pi and 6 wide. 2 cos 2x plus 3. Okay, 2, make sure it's in radians, cos 2x plus 3, define it, define f of x. Okay, so we had the width is pi on 6, and then times f of pi on 6, and then plus f of pi on 3, then it's going to be f of pi on 2, f of pi divided by 2, 7 pi on 6. Okay, what? James approximation as a fraction of the exact area. Oh, wow. Exact area is from 0 to pi on 2 dx. Where's x? There. So I want that divided by that, 7 on 9. 7 and 9. Okay, the turning point of the parabola, that is closest to the origin when? Okay, the turning point is negative b on 2a. So here, b is negative 2b, so it's going to be 2b on 2 times 1, which is just b. Okay, so b, if b is the x value of the turning point, what's that going to look like? B is the x value of the turning point. X squared minus 2bx plus 1. X squared minus 2b times b x minus 1. What? X squared minus 2 times x minus 1. What is that? When did I define x to be something? What? Jesus, I just worked out y. That's supposed to be y equals pace. Okay. X squared minus 2bx minus y. Okay, so if x is 1, think here. If b was 1, plus 1. Okay, I've got a turning point at 0, 1. Then when b equals 1, it's going to be a distance of 1 and 1. What about if I made it be halves? So that would be a half, and then when I put a half into that function, what do I get? If b is a half, what's my y turning point? Let's come back to that one. Jesus, maybe not. Okay, so my b coordinate is my x value, and then if I sub that value in, I should get my y coordinate. So, where are we? So this, copy, paste, given b equals 1/2, I get 1, and then if I did 1, I get 0, so my y coordinate 0. What about 1 divided by root 2? X squared plus y squared, because I want my shortest distance. So if I did that squared, plus that squared. I get 0.843. If I did 1, I get 0 and 1. So the square root of that is 0.981. So that one's the smallest so far. If I did b was a quarter, so I'd get 1.5. Then I'd get 1 on 4. So if I do a quarter, if b equals a quarter, y equals 1.5. Was that right? Go back on. B is a quarter. F min. So I've got a quarter, 0.9375. If B is a half, I've got a half, 3/4. Okay, sorry, I'm getting text messages. Okay, B equals a half, B equals a quarter, B equals 1. So a half, 3/4, if I find that distance, a half squared plus 3/4 squared and square rooted. Okay, so we know that's shorter than the other one. So I've got a half, 3/4. If I got 1, I get 1, 0. And if I get 0, I get B as 0. I get 1. If B is 1 divided by root 2, come on, you stupid thing. Analysis G solve F min. Okay, 1 on root 2 and a half. 1 on root 2. So 1 on root 2 and a half. So that's 0.866. What was that for? 1 on root 2. What about a quarter? Min. A quarter, 0.9375. A quarter, 0.9375. 0.97. So I'm thinking 1 on root 2 and a half is our winner. Stupid thing. Those. Time will tell. I'll get backlash if it's wrong. Okay, consider the functions, all real positive numbers, x to the p on q and x to the m on n, they're all positive integers. P and q are in their simplest form. F of x is greater than g of x. Okay, so x to the p on q, x to the m on n. X to the p on q. I'm going to define them. x to the power of p divided by q define that as f of x, and x to the power of m divided by n, and that's going to be my g of x. I feel like this is taking a lot longer than multiple choice has in the past, if that makes anyone feel better. Define g of x. Okay, let's sketch them. F of x, g of x. Okay, sometimes it's stupid when it does this. X to the power on q, and copy. And the other one is x to the m on n. Okay, sketch those. Okay, we don't have an n, so let's say given n, we'll just say it equals 3. Okay, so here, I've got a hard copy of the exam, so I'm going to read what it says. Okay, f of x is greater than g of x for 0 to 1. F of x is the blue one. Yeah, it is. If q is greater than n, so let's say if q is greater than n, q is greater than n, so it's definitely, and p is equal to m. So let's say p is equal to m. Okay, zoom in. It is greater than it, yep. If m is less than p, m is less than p, and q is equal to n. Oh, so if m is greater than p. Okay, so if m is greater than p, then f of x is still larger. Pn is less than qm. Pn, 3 times 3, qn, qm. Yeah, that still holds if qm is greater than, if it's equal, then they're the same. Okay, f dash of c is equal to g dash of c. Between there, nice question, Jelly. Just really annoying. Okay, ddx and ddx of that. Oh. No, I don't want to do that. I just want to get rid of that. ddx of x to the m on n. Okay. Now this doesn't give any parameters, but it just says to look at the gradients. Okay. So here, they're the two gradients. They're going to be equal between 0 and 1. Whereas this one goes to infinity by the time it gets to 1. So the gradients are the same between 0 and 1, but between 1 and infinity, they're not. They're never going to be the same. So that's our answer. The gradients aren't the same between 1 and infinity. Okay, another one. That and that are symmetrical. Higher minus lower. Okay, 0 to 3. It's never going to be that. 2 times 3 on 5. And then, which one's which? Sine Okay, so that's sine, and that's cos. I don't care that they're not x. Sine x, okay, it's not going to be that either. 0 to 1/3 of cos, yeah, that's higher, so that's right. -2 1/3, 1/3 to there, and then because I've got cos x minus sine of x, they're the wrong way around, so we've got a negative out the front. So that's all right for those two areas. This area, sine is above, so we've got a negative out the front, and we've got cos, and then 3 on 5. That's our answer, because that is correct. Cos is above. Here, when I go from 1/3 to 1, and I multiply it by 2, I get that area and that area. 1/3 to 1, cos is below sine, so that's why I put a negative out the front. And then negative 3 on 5 to 3, but our cos is below, so basically it's the same as flipping that around and changing that to a positive, but that's definitely our answer. Okay, the differential function has a probability density function. It's known that the median of the probability density function of f is at O. F dash of O equals, f dash of 0 equals 4. So my gradient at 0 is 4. The transformation maps the graph of f to the graph of g. G is a probability density function with a median at 0. So it's got a median of 0, and g dash of 0 is -1. So g dash of 0 is -1, so it's not as steep. Okay, so if we want to go from a gradient of 4 to a gradient of 1, we're going to have to reflect it. We can't put in the y-axis because we're going to end up with in the x-axis because we're going to end up with negative probabilities, which won't happen. So if we reflect it in the y-axis, we'd get a gradient of -4. So scrap, 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 because we want to reflect it in the y-axis. Okay, if we dilate it a half, that's going to make our gradient steeper. And then if we do it factor 2, that's going to make it go further away, so it's going to make it steeper again. So I don't think it's that. I think it is this last one. So if I have a gradient of 4, if I reflect it in the y-axis and dilate it, so reflect it in the y-axis, dilate it by factor 2, it's going to get smaller. And then if I do it a half from the x-axis, it's going to get smaller again by a factor of 4, because I'm dilating it by 2 and then I'm dilating it by a half. So that's our answer. 28. Now, did I answer them all? I think I did. I felt like I skipped something. Alright, hopefully that's right. Hope you went okay. This took longer than it usually would. I think there's lots and lots of twists in it.